I'm Dennis Danielson. I'm prof in the English department, and I think they wanted to find someone even older than today's speaker to introduce him. This is a student event, and it's a privilege for me to be here and to introduce our speaker today. You've heard his name, William Lane Craig. He is a research professor of philosophy, and boy, he's a large group of students from the pure philosophy. He's a professor of philosophy at Loyola University in Southern California. Dr. Craig holds 2 PhDs, one from the University of Birmingham and another from the University of Munich. I spent some time at the University of Munich last year, so he doesn't mind if we call him Bill, but it wouldn't be amiss if you called him Dr. Craig. He is the author of many books and articles. He has an astonishing record of speaking engagements, even over the last few days here in the Vancouver area. His website is worth a visit. It's called reasonablefaith.org. Reasonable Faith, all one word. And let me assure you that he has a considerable presence on YouTube. So if you want to follow up after today's lecture, just go onto YouTube and find him. Sometimes in debates, sometimes in debates with empty chairs, sometimes in the lecture format. His books include such modest titles as Time and Eternity. He's the editor of Blackwell Companions in Natural Theology and many others that are too numerous for me to list. The topic today is fine-tuning. He's going to tell you a lot more about that than I can. But 5 years ago, the cosmologist Paul Davies published a book in English called The Goldilocks Enigma. And the question of that book is, how is it that our universe, like baby bear's porridge, is, at least as far as cosmology is concerned, just right? The book was released in North America with the less literary title, Cosmic Jackpot. The question all serious cosmologists ask, and a lot of other thoughtful human beings who aren't cosmologists, is this. Why, given the staggering mathematical and physical odds against there being a universe like ours, does our universe exist at all? And how can it be so astonishingly fine-tuned? As you can guess, there are many answers to this question out there. Edward Tryon, a scientist writing in the prominent journal Nature in 1973, proposed that our universe is, and I quote, just one of those things that happens from time to time. I strongly suspect Dr. Craig will propose a less flippant sounding answer today. Please join me in welcoming Dr. William Lane Craig.
With you this morning. I've enjoyed my time here in Vancouver so far. I've been speaking at Simon Fraser University and then at Trinity Western University, as well as a conference in Abbotsford. We'll go on tomorrow to the University of Calgary, where I'll be speaking and also doing another conference. But it's good to spend this time today with you at UBC. The ancient Greek philosophers were struck with the order that pervades the cosmos. The stars and the planets and their constant revolution across the night sky were especially awesome to the ancients. Plato's Academy lavished extensive time and thought on the study of astronomy because Plato believed it was the science that would awaken man to his divine destiny. According to Plato, there are 2 things that lead men to believe in God. The argument from the existence of the soul and the argument from the order of the motion of the stars and of all things under the dominion of the mind which ordered the universe. Plato employed these arguments to refute atheism and concluded that there must be a best soul who is the maker and father of all, the king, who ordered the primordial chaos into the rational cosmos that we observe today. Aristotle, too, was filled with wonder at the majestic sweep of the glittering host across the night sky of ancient Greece. Anyone who has personally studied the heavens must turn a sympathetic ear to these men of antiquity, who gazed up into the night sky, as yet undimmed by pollution and the glare of city lights, and watched the slow but irresistible turn of the cosmos, replete with its planets, stars, and familiar constellations, across their view, and wondered, what is the cause of all this? Aristotle concluded that the cause was divine intelligence. In his metaphysics, Aristotle proceeded to argue that there must exist a first uncaused cause, which is God, a living, intelligent, immaterial, eternal, and most good being who is the source of order in the cosmos. Today, many astronomers and astrophysicists, as a result of recent discoveries, are coming to a similar conclusion. Scientists used to think that whatever the very early universe might have been like, given sufficient time and some luck, intelligent forms like ours would eventually evolve somewhere. As a result of discoveries over the last 40 years or so, we now know that that assumption was wrong. In fact, quite the opposite is true. Astrophysicists have been stunned by the discovery how complex and delicate a balance of initial conditions must be given in the Big Bang itself if the universe is to permit the evolution and existence of intelligent life anywhere at all in the cosmos. This delicate balance of initial conditions has come to be known as the fine-tuning of the universe for life. We've come to discover that the universe is fine-tuned for the existence of intelligent life with a complexity and delicacy that literally defy human comprehension. There are at least two kinds of fine-tuning. The first involves the constants of nature, and the second involves certain arbitrary physical quantities. First, the constants of nature. What is a constant? Well, when the laws of nature are expressed as mathematical equations, you find appearing in them certain symbols which stand for unchanging quantities, like the force of gravity, the electromagnetic force, and the subatomic weak force. These unchanging quantities are called constants. The value of these constants is not determined by the laws of nature. There could be universes governed by the same laws of nature, even though these constants have very different values. So, the actual values of these various constants are not determined by nature's laws. Depending on the values of these constants, universes governed by the same laws of nature will look very different. In addition to the constants, there are certain arbitrary quantities which are just put in as initial conditions on which the laws of nature operate. Because these quantities are arbitrary, they're also not determined by the laws of nature. An example would be the amount of thermodynamic disorder or entropy in the early universe. It's just given in the Big Bang as an initial condition, and the laws of nature then take over and determine how the universe will develop from there. If the initial quantities had been different, then the laws would predict that a quite different universe would evolve. Now, what scientists have been surprised to discover is that these constants and quantities must fall into an exquisitely narrow range of values if the universe is to be life-permitting. This is what is meant by the fine-tuning of the universe for life. So, the term fine-tuned does not mean designed. The expression is a neutral term, which doesn't say anything about how the fine-tuning is best explained. Fine-tuning just means that the range of life-permitting values for those constants and quantities is extremely narrow in comparison to the range of possible values. If the values of even one of these constants or quantities were to be altered by less than a hair's breadth, the life-permitting balance would be destroyed and the universe would be life-prohibiting instead. So, fine-tuning in this neutral sense is uncontroversial and well-established. Physics abounds with examples of fine-tuning. Before I share a few examples, let me give you some numbers to give you a feel for the delicacy of the fine-tuning. For example, the number of seconds in the entire history of the universe is around 10 to the 17th power. That's 1 followed by 17 zeros. The number of subatomic particles in the entire known universe is said to be around 10 to the 80th power. That's 1 followed by 80 zeros. Now these are simply incomprehensible numbers. Now, with those numbers in mind, consider the following. Both the force of gravity and the subatomic weak force are so finely tuned that an alteration in their values by even 1 part out of 10 to the 100th power would have prevented a life-permitting universe. Similarly, a change in the value of the so-called cosmological constant, which drives the acceleration of the universe's expansion, by as little as 1 part out of 10 to the 120th power would have rendered the universe prohibiting. Here's a real corker. Roger Penrose of Oxford University has calculated that the odds of the universe's initial low entropy conditions obtaining by chance alone is on the order of 1 chance out of 10 to the power of 10 to the power of 123. A number which is so inconceivable that to call it astronomical would be a wild understatement. The fine-tuning here is beyond comprehension. Having an accuracy of even 1 part out of 10 to the 60th power is like firing a bullet toward a target at the other side of the observable universe, 20 billion light years away, and nailing a bullseye 1 inch in diameter. The examples of fine-tuning are so many and so various that they aren't likely to disappear with the advance of science. Like it or not, fine-tuning is just a fact of life, which is scientifically well established. Now, some of you might be thinking, but if the constants and quantities had had different values, then maybe different forms of life might have evolved. But that underestimates the truly disastrous consequences of a change in the value of these constants and quantities. When scientists talk about a universe as being life-permitting, they're not talking about just present forms of life. By life, scientists just mean the property of organisms to take in food, extract energy from it, grow, adapt to their environment, and reproduce. Anything that can fulfill those functions counts as life. And the point is, in order for life so defined to exist, whatever form it might take, the constants and quantities of the universe have to be unbelievably fine-tuned. Otherwise, disaster results. In the absence of fine-tuning, not even matter, not even chemistry would exist, much less stars and planets where life might evolve. Now, sometimes people will object, but maybe in a universe governed by different laws of nature, such disastrous consequences might not result. But this objection betrays a misunderstanding of the argument. We're not concerned with universes governed by different laws of nature. We have no idea what such universes might be like. Rather, we are concerned solely with universes governed by the same laws of nature, but with different values of the constants and quantities. The Canadian philosopher John Wesley of the University of Uquetv gives the following illustration. He invites us to imagine a solitary fly resting on a large blank area of the wall. A single shot is fired and the bullet strikes the fly. Now, even if the rest of the wall outside the huge blank area were absolutely covered with flies, so that a randomly fired bullet would probably hit one, nevertheless, it remains highly improbable that a single randomly fired bullet would strike the solitary fly within the large blank area. In the same way, we need concern ourselves only with universes governed by the same laws of nature in order to determine how likely it is that one of them would be life-permitting. Because the laws of nature are the same, we can determine what would happen if the constants and quantities were to be altered, and the results turn out to be disastrous. A life-permitting universe is like that solitary fly on the wall. The question we face then is this: what is the best explanation of this cosmic fine-tuning? Many people think that the reason the universe is finely tuned for life is because it was designed to be life-permitting by a cosmic designer. But design is not the only alternative. There is also physical necessity and chance. The key to inferring design as the best explanation will be eliminating these other two alternatives. Accordingly, we can present a very simple three-step argument. Premise 1, the fine-tuning of the universe is due to either physical necessity, chance, or design. Premise 2, it is not due to physical necessity or chance, from which it follows logically. 3, therefore, it is due to design. Now, this is a logically valid argument whose conclusion follows necessarily from the two premises. So, the only question is whether those premises are more plausibly true than false. So let's look at each of them together. The first premise, that the fine-tuning of the universe is due to either physical necessity, chance, or design, is unobjectionable because it simply lists the three alternatives available for explaining the fine-tuning. If someone has a fourth alternative, he's welcome to add it to the list, and then we'll consider it when we come to premise 2. But there doesn't seem to be another live option in addition to the three which are listed here and are widely discussed in the literature. So the crucial premise is the second premise, that the fine-tuning is not due to physical necessity or chance. Let's examine each of these alternatives in turn. Now, according to the first alternative, physical necessity, the universe has to be life permitting. The constants and quantities must have the values they do so that a life prohibiting universe is physically impossible. Now, on the face of it, this alternative seems fantastically implausible. It would require us to say that a life-prohibiting universe is a physical impossibility. But why take such a radical view? The constants, as we've seen, are not determined by the laws of nature. So why couldn't they be different? Moreover, the arbitrary quantities are just arbitrary boundary conditions on which the laws of nature operate. Nothing seems to make them necessary. So the opponent of design is taking a radical line here that requires some evidence. But there is none. The alternative is just put forward as a bare possibility. Now, sometimes scientists do talk of a yet-to-be-discovered theory of everything, or TOE, T-O-E. But like so many of the colorful names given to scientific theories, this label is very misleading. A successful TOE would enable us to unify the four basic forces of nature: gravity, the weak force, the strong force, and electromagnetism, into a single force carried by a single kind of particle. But it wouldn't even attempt to explain literally everything. For example, the most promising candidate for a TOE today, so-called M theory, or superstring theory, only works if there are 11 dimensions. But the theory itself cannot explain why just that particular number of dimensions should exist. Moreover, M theory doesn't predict uniquely a life-permitting universe. It permits a vast range of around 10 to the 500th power different possible universes, all consistent with the same laws, but carrying different values of the constants of nature. Almost all of these possible universes are life-prohibiting. This so-called cosmic landscape permitted by M theory has become something of a phenom lately. It's important to understand that the landscape is just a range of possibilities. Some people have misrepresented it to mean that all of these different universes actually exist. Some have thought that it undermines the argument for design because the landscape must include within it life-permitting worlds like ours. But the cosmic landscape is not real. It's just a list of possibilities. It describes the range of universes that are consistent with M theory. That range is so huge, 10 to the 500th power different possibilities, that some explanation is needed for why a life-permitting universe exists, since life-permitting universes are a practically infinitesimal part of the landscape. So, you can't say that life-permitting universes are physically necessary, because on M theory at least, that's clearly false. So, there's no evidence that a life-permitting universe is physically necessary. Quite the contrary. All the evidence indicates that life-prohibiting universes are not only possible, but far, far more likely than any life-permitting universe. That leads to the second alternative. Could the fine-tuning be due simply to chance? According to this alternative, it's just an accident that all the constants and quantities fall into the life-permitting range. We basically lucked out. The fundamental problem here is that the chances of a life-permitting universe existing are so remote that this alternative becomes unreasonable. Sometimes people object that it's meaningless to speak of the probability of a fine-tuned universe's existing, because there is, after all, only one universe. So you can't say that 1 out of every 10 universes, for example, is life permitting. But the following illustration from the physicist John Barrow clarifies the sense in which a life-permitting universe is improbable. He invites us to take a sheet of paper and place upon it a red dot. That dot represents our universe. Now, alter slightly one or more of the finely tuned constants and physical quantities which we've been discussing. As a result, we have a description of a new universe, which we can represent as a new dot on the piece of paper in the neighborhood of the first. If that new set of constants and quantities describes a life-permitting universe, make it a red dot. If it describes a universe which is life-prohibiting, make it a blue dot. Now, repeat the procedure over and over and over again until the page is filled with dots. What you wind up with is a sea of blue with only a few pinpoints of red. That's the sense in which it is overwhelmingly improbable that the universe should be life-permitting. There are simply vastly more life-prohibiting universes in our local area of possible universes than there are life-permitting universes. Now, sometimes people will try to justify the chance alternative by appealing to the analogy of a lottery. In a lottery where all the tickets are sold, it's fantastically improbable that any one person should win. Yet somebody has to win. It would be unjustified for the winner, whoever he may be, to say, the odds against my winning were 20 million to 1, and yet I won. The lottery must have been rigged. In the same way, they say, some universe out of the range of possible universes has to exist. The winner of the universe lottery would also be unjustified to think that because his universe exists, this must have been the result of design, not chance. All the universes are equally improbable, but one of them, by chance, has to win. Now, this analogy is actually very helpful because it enables us to see clearly where the objector has misunderstood the argument for design and then to offer a better, more accurate analogy in its place. Contrary to popular impression, the argument for design is not trying to explain why this particular universe exists. Rather, it's trying to explain why a life-permitting universe exists. The lottery analogy was misconceived because it focused on why a particular person won. The correct analogy would be a lottery in which billions and billions and billions of white ping pong balls were mixed together with just one orange ping pong ball. And you were told that one ball will be randomly selected out of the horde. If it's orange, you'll be allowed to live. If it's a white ball, you'll be shot. Now, notice that any particular ball which is selected is equally improbable. No matter which ball rolls down the chute, the odds against that particular ball are fantastically improbable. But some ball must roll down the chute. This is the point illustrated by the first lottery analogy. That point, however, is irrelevant because we're not trying to explain why this particular ball was picked. The relevant point is that whichever ball rolls down the chute, it is overwhelmingly more probable that it will be white rather than orange. Getting the orange ball is no more improbable than getting any particular white ball. But it is incomprehensibly more probable that you will get a white ball instead of an orange one. So if the orange ball rolls down the chute, you certainly should suspect that the lottery was rigged to let you live. If you still don't see the point of this analogy, then imagine that in order to be allowed to live, the orange ball had to be randomly picked 5 times in a row. If the odds against getting an orange ball even once are great enough, then happening 5 times rather than once won't really affect the probability significantly. But if such a thing actually happened, everyone would recognize that it did not happen by chance. So, in the correct analogy, we're not interested in why you got the particular ball you did. Rather, we're puzzled why, against overwhelming odds, you got a life-permitting ball, rather than a life-prohibiting ball. That question is just not addressed by saying, well, some ball had to be picked. In the same way, some universe has to exist. But whichever universe exists, it is incomprehensibly more probable that it will be life-prohibiting rather than life-permitting. So we still need some explanation why a life-permitting universe exists. Some people have argued that no explanation is needed for why we observe a life-permitting universe, because that's the only kind of universe we can observe. If the universe were not life-permitting, then we wouldn't be here to ask about it. This is the so-called anthropic principle, which says that we can observe only properties of the universe which are compatible with our existence. This reasoning is, however, fallacious. The fact that we can observe only life-permitting universes does nothing to eliminate the need of an explanation for why a life-permitting universe exists. Again, an illustration can help. Imagine that you're traveling abroad and arrested on trumped-up drug charges, and you're dragged in front of a firing squad of 100 trained marksmen, all with rifles aimed at your heart, to be executed. You hear the command given, ready, aim, fire! And you hear the deafening roar of the guns. And then you observe that you're still alive, that all of the 100 marksmen missed. Now, what would you conclude? Well, I guess I shouldn't have been surprised that they all missed. After all, if they hadn't all missed, I wouldn't be here to be surprised about it. Given that I am here, I should have expected them all to miss. Nothing to be explained here. Well, of course not. It's true that you shouldn't be surprised that you don't observe that you're dead, since if you were dead, you wouldn't be able to observe it. But you should still be surprised that you do observe that you are alive, in light of the enormous improbability of the marksmen all missing. Indeed, you'd probably conclude that they all missed on purpose, that the whole thing was a setup, engineered for some reason by someone. Theorists have therefore come to recognize that the anthropic principle cannot eliminate the need of an explanation of the fine-tuning unless it's conjoined with a many worlds hypothesis. According to that hypothesis, our universe is but one member of a world ensemble or multiverse of randomly ordered universes undetectable by us, preferably infinite in number. If all of these other universes are really out there, then by chance alone, life-permitting worlds will appear somewhere in the world ensemble. Since only finely tuned universes have observers in them, any observers existing in the world ensemble will naturally observe their worlds to be finely tuned. So, no appeal to design is necessary to explain fine-tuning. It's pure chance. Now it's worth pausing for a moment to reflect on what's happening here. The current debate over fine-tuning has now become a debate over the many worlds hypothesis. This hypothesis is at the heart of the discussion today. In order to explain fine-tuning, we are being asked to believe not merely that there are other unobservable universes, but that there is an infinite number of such worlds, and moreover, that they randomly vary in their fundamental constants and quantities. All of this is needed to guarantee that a life-permitting universe like ours will appear by chance in the ensemble. Now, this is really quite extraordinary. It's a sort of backhanded compliment to the design hypothesis. For otherwise sober scientists would not adopt so speculative and extravagant a view as the many worlds hypothesis unless they felt absolutely compelled to do so. The fact that theorists are turning to the many worlds hypothesis to rescue the alternative of chance is perhaps the best evidence that appeal to chance is in trouble. The odds against the existence of a life-permitting universe are just too great to be faced unless you embrace the hypothesis of a world ensemble. Now, one way to respond to the many worlds hypothesis would be to show that the multiverse itself also involves fine-tuning. For in order to be scientifically credible, some plausible mechanism must be suggested for generating the many worlds. But if the many worlds hypothesis is to be successful in attributing fine-tuning to chance alone, then the mechanism that generates the many worlds had better not be fine-tuned itself. For if it is, then the problem arises all over again. But the proposed mechanisms for generating a world ensemble are so vague that it's far from evident that the physics governing the multiverse will be free of any fine-tuning. For example, inflationary cosmology, which is appealed to in order to actualize all of the possibilities in the cosmic landscape, may well involve fine-tuning. So the postulate of a world ensemble is by itself not enough to justify the alternative of chance. Moreover, many theorists are skeptical of the many worlds hypothesis itself. Why think that a world ensemble actually exists? The so-called Born-Guth-Vilenkin theorem, discovered in 2003, requires that even a multiverse of bubble universes must have a beginning. In that case, the mechanism that generates the bubble universes has been chugging away only for a finite amount of time. So by now, there may well be only a finite number of universes in the world ensemble, which may not be enough to guarantee the appearance of a finely tuned universe by chance alone. Moreover, why think that they are randomly ordered? There's no evidence that the sort of world ensemble required by the many worlds hypothesis actually exists. Third, and most fundamentally, the many worlds hypothesis faces what appears to be a devastating objection. Namely, if we were just a random member of a world ensemble, then we ought to be observing a very different universe. Roger Penrose of Oxford University has calculated that the odds of our solar systems forming instantaneously by the random collision of particles is incomprehensibly more probable than the universes being fine-tuned. So, if we were just a random member of a world ensemble, we should be observing a patch of order no larger than our solar system. Worlds like that are simply incomprehensibly more plentiful in the world ensemble than worlds like ours, and therefore ought to be observed by us if we were but a random member of such an ensemble. Indeed, in order to be observable, the patch of order needn't be even as large as our solar system. The most probable observable world would be one in which a single brain fluctuates into existence out of the quantum vacuum and observes its otherwise empty world. So, if we were just a random member of a world ensemble, it is overwhelmingly probable that we ought to be observing a world like that. In other words, the observer self-selection effect appealed to by the anthropic principle is explanatorily vacuous. It does not suffice to show that only finely tuned universes are observable. As the philosopher Robin Collins has noted, what needs to be explained is not just intelligent life, but embodied, interactive, intelligent agents like ourselves. Appeal to an observer self-selection effect accomplishes nothing because there is no reason to think that most observable worlds are worlds in which that kind of observer exists. Indeed, the exact opposite appears to be true. Most observable worlds in the world ensemble will be worlds in which a single brain exists as a result of a quantum fluctuation. I find it amazing that so metaphysical a speculation as the world ensemble hypothesis should be susceptible to refutation. One might think that there's just a standoff between so speculative a hypothesis and the hypothesis of design. But Penrose's argument seems to show otherwise. The world ensemble hypothesis fails as an explanation of the fine-tuning of the universe for interactive agents like ourselves. With the failure of the many worlds hypothesis, the last ring of defense for the alternative of chance collapses. Neither physical necessity nor chance provides a good explanation of the fine-tuning of the universe. So, what about that third alternative, design? Is this explanation better than physical necessity or chance, or is it equally implausible? Detractors of design sometimes object that on this hypothesis, the cosmic designer himself remains unexplained. This objection is what Richard Dawkins calls the central argument of my book, The God Delusion. Dawkins' claim is that one is not justified in inferring design as the best explanation of the complex order of the universe, because then a new problem arises, namely, who designed the designer? This objection, however, is flawed on at least two counts. First, in order to recognize an explanation as the best, you don't need to have an explanation of the explanation. This is an elementary point in the philosophy of science. If archaeologists digging in the earth were to discover things looking like arrowheads and pottery shards, they would be justified in inferring that these artifacts are not the chance products of sedimentation and metamorphosis, but rather products of some unknown group of people, even though they have no explanation of who these people were or where they came from. Similarly, if astronauts were to come upon a pile of machinery on the backside of the moon, they would be justified in inferring that it was the product of intelligent agents, even if they had no idea whatsoever who these agents were or how they got there. In order to recognize an explanation as the best, you don't need to be able to explain the explanation. In fact, if you think about it, such a requirement would lead to an infinite regress of explanations so that nothing could ever be explained, and science would be destroyed. For before any explanation of some phenomenon could be acceptable, you'd need an explanation of the explanation. But before you could expect that, you'd have to have an explanation of the explanation of the explanation. And before you could accept that, you'd need an explanation of the explanation of the explanation of the explanation. And before that, and so on to infinity. Nothing could ever be explained. So, in the case at hand, in order to recognize that design is the best explanation of the appearance of design in the universe, one needn't be able to explain the designer. Whether the designer has an explanation can simply be left an open question for future inquiry. Second, Dawkins thinks that in the case of a divine designer of the universe, the designer is just as complex as the thing to be explained, so that no explanatory advance is made. Now, this objection raises all sorts of questions about the role played by simplicity in assessing competing explanations. For example, there are many other factors besides simplicity that scientists weigh in determining which explanation is the best, such as explanatory power, explanatory scope, plausibility, and so forth. An explanation which has broader explanatory scope may be less simple than a rival explanation, but still be preferred because it explains more things. Simplicity is not the only or even most important criterion for assessing theories. But leave those questions aside. Dawkins' fundamental mistake lies in his assumption that a divine designer is just as complex as the universe. That is plainly false. As a pure mind without a body, God is a remarkably simple entity. A mind is not a physical object composed of parts. In contrast to the contingent and variegated universe with all of its inexplicable constants and quantities, a divine mind is startlingly simple. Now, certainly, such a mind may have complex ideas. It may be thinking of the infinitesimal calculus, for example, but the mind itself is a remarkably simple spiritual entity. Dawkins has evidently confused a mind's ideas, which may indeed be complex, with a mind itself, which is an incredibly simple entity. Therefore, postulating a divine mind behind the universe most definitely does represent an advance in simplicity, for whatever that may be worth. Therefore, it seems to me that of the three alternatives before us, namely physical necessity, chance, or design, the most plausible of the three is design. And thus I think we have a good argument in support of the existence of a cosmic designer. Well, thank you very much.